So today we are going to talk about Laplace transforms involving unit step functions. Now regarding the unit step function, there are different notations depending on different authors who use transformations involving unit step functions. One of the authors, one of the textbooks actually authored by Calder and Johnson uses the notation, which I will write on the side note here, h of t minus a. And that notation is the same as what I'm about to use. It means exactly the same thing. H here stands for a Heaviside function, Heaviside, is the Heaviside function, which is the same as a unit step function. The notation I'm about to use is as follows. I'm going to use the following. So here is our simplest unit step function. We're going to denote that by u with a subscript of alpha, and this is basically, it's a function of t. So in the problems following this, when you see a u alpha, basically it's a function of t. So u alpha or u alpha of t, here's the function notation. This is a piecewise function, and it is either 0 or 1. It only has binary values, 0 or 1. So the function is 0 for values of t between 0 and alpha. Because remember, our transform domain is from 0 to infinity, so we start the t value at 0. And then it's 1 starting at alpha all the way up to infinity. So here are a few examples of the unit step functions. So here's my vertical axis and the horizontal axis. Let's start with the basic unit step function, the most basic unit step function, which I would like to call u0. So here is my f of t, or the vertical axis. Here is my t-axis, which is horizontal. And so u0, if I write it out, well, it's just 1. Because notice over here that whatever alpha is, that's where the domain for the value of 1 starts. So this is actually just 1, given that t is greater than or equal to 0, because the 0 part is eliminated. So the graph of this would simply be a horizontal line passing through 1 on the vertical axis, and it shall continue all the way to infinity. Likewise, here is another example. Again, my horizontal axis is the t-axis, and I have graphed my vertical axis as f of t. Now, let's suppose we want to graph u2. So u2, if I'm to write this as a piecewise function, it is going to be 0 for the values of t between 0 and 2, and then it's going to be a 1 for the values of t at and following 2. And so if I graph this function, let's suppose that here is 2, on the t-axis, on the horizontal axis. So all the way up to 2, starting at 0. So from 0 to 2, the function is 0. So it is this blue horizontal line that I have drawn. Now at 2, notice the blue graph or the blue line will have an open circle because 2 is not included in the domain of 0. However, 2 is included in the domain of 1, which is our red function. So if I mark 1 on the vertical axis, at t equals 2, I will have a solid dot at the point 2, 1. So those are the coordinates of this red dot, 2, 1. Then this function will continue all the way to infinity. So as you can see, it's a step function. In general, we can graph this function as follows. So basically, if I have my vertical axis and horizontal axis, and in general, let me say that I'm graphing u alpha of t. So u alpha, again, as noted over here, it can either be 0 or 1. And also let me color code that. So 0 will be graphed in blue. So it will be 0 for all the values of t starting at 0 and all the way up to alpha, not including alpha. And let's say the 1 we will graph in red. And it will be, the function will be 1 at alpha and for all the values of t after alpha. So let's suppose that here is my arbitrary alpha, and again remember, alpha you can choose to be anything you want. It could be 2, for instance, 0, 1/2, square root of 5, it could be pi, it could be e, it could be any real number as far as that number is non-negative. And let's suppose that on the vertical axis here is 1. Then, starting at t equals 0, all the way up to t equals alpha, the function will be this blue horizontal line along the t-axis. It will be open at t value of alpha, and then the function 1 starts at the coordinate point alpha 1, and it continues all the way to infinity. Okay, so here are 3 examples of unit step functions.